These are electrostatics conceptual questions, number 21 through number 30. A conductor differs from an insulator in that a conductor has those loose electrons. So if you remember, copper has some extra electrons just kind of floating really far away from the center of the nucleus. And because they're so far away, we say that they're pretty loose, and they're able to be stripped off and used. Other electrons then will come in and replace those. So that's the difference. If you remember, an insulator like carbon would have electrons that would be really close to the nucleus. They'd be a lot harder to remove. For number 22, it says semiconductors. The picture that you see here, these are all semiconductors. You find semiconductors in all modern electronic devices like your cell phone or in a computer or in your LED or LCD or plasma TV. And they have some really cool properties. They can be very good insulators, so they won't conduct electricity. Then you can also change them to make them conduct electricity very well, and that occurs because you have impurities in each one of these chips, and those impurities are there on purpose in order to make sure that those can do both insulate and conduct electricity. The next one is number 23, and in number 23 it says a negatively charged rod is brought near a metal can. So here is our negatively charged rod. That rod is facing into the board, and it's brought close to this can. So here's our can. You'll notice that when this happens, you are able to get what we call a polarized, so this is polarized effect, where the opposite charge will go toward the negative charge, and then the same charge, which is negative, will get pushed to the other side. If you touch this can with your finger, the negative charges, which are closest to your finger, will travel down your finger, and then when you remove this rod or move it this way, then the charges will distribute evenly over the surface of the can. So in the end, the can is then positively charged. For number 24, an electroscope, we've played with these in class, is charged positively. So if you remember in the electroscope we had, it's got the ball on the top and then there's two metal leaves that are down on the bottom. So this one is charged positively, as shown by foil leaves that stand apart because there is positive charge on here. As a negatively charged rod is brought close to the electroscope, the leaves move closer together. And the reason for that is this rod is negative, and so we have some of this negative charge will attract the positive charges, and those positive charges will move up. And as they move up, the two little leaves here become neutral, and they end up coming back together. So it's also explained here, the positive charges move toward the top of the electroscope, reduces the charge on the leaves, and they do come together. For the next one, number 25, a lightning bolt will occur between a couple of different things. One of them is they can go cloud to cloud. So you'll see this bolt right here is just moving from cloud to cloud, and then you have your other bolt which moves from the cloud down to the ground. For number 26, to charge an object by induction, the process of grounding, it either may or may not occur. If you remember our can, we had positive charges on one side, we had negative on the other. Then we took our finger and we touched the can, and those charges then traveled down through our finger. You don't have to do this in order for induction to happen. It's more of a polarization, but it does not have to be grounded at all. Number 27, when a charged cloud passes overhead, the ground below is charged by induction. So if you have a cloud and it's up above the ground and that cloud is negatively charged, this cloud is not touching the ground, but we know that the ground will have positive charges move. So we know that the ground is positive here, and then the just a little bit below the ground we would have negative charges, and that's from the repulsion of the cloud negative charges. So here, this is induction. There's no touching going on at all. For the next question, which is number 28, it says bring a charged object near a conductor and then momentarily touch the conductor. This demonstrates charge by induction. So just another definition of induction. For number 29, a rubber balloon will stick to a wall. So here's our balloon sticking to the wall. And it's because of polarization. Remember we said that there are charges in the wall that get separated. So this side of the wall is more positive, this side of the wall is more negative. You'll notice the balloon is negative on this side, which attracts to the positive charges on this side of the wall, and that balloon appears to stick to the wall. So electrostatics, or the static electricity, is much stronger than gravity. Gravity cannot pull this down because the wall has too big of an electric force, and that trumps the gravity force. Then finally, number 30, which is the last question, says electrical polarization occurs when charge distribution and a neutral molecule separates. So all that means is that on one side of the molecule you'll have positive, and on the other side you'll have negative. Water does this really well. So if I have a molecule of water, it tends to have a couple of extra electrons here on one side. So we say this side of the atom is negative, or the molecule is negative, and then this side, because of the hydrogens, is more positive. And that is number 11 through number 30.